Right, so again, for the tangent and cotangent, we are adding in those little rest stops for the halfway points on the circle. So let's go ahead and do the first one. I'm gonna do this one a little slower than usual because, the circle just got a little bit more complicated. At 0 pi, you're right here. How do you get tangent? Like when we did sine, it was the y value, cosine was the x value, etc. How do you get tangent? Y over x. Maybe like make a note of that. Tangent is going to be y over x. So at your first point, that would be right here. So that would be what over what? 0 over 1. Is that 0 or is that undefined? That's 0. All right, now pi over 4 is right here. If you put this over this, again, it would look awful, but anything over itself is 1. So that just comes out to be 1. Pi over 2, now we're at the tippy top. If you put y over x, that's 1 over 0. Now that is where you get an undefined. Okay, good. All right, 3 pi over 4. Just watch me point to it. That's right here. Anything over itself is 1, but that will actually come out to be -1. Good. Cool. This is going well. And then pi is right here. If you put y over x, 0 over -1 is just 0. 0 in the numerator just gives you 0. It's when you try to divide by 0, you get an undefined. All right, now we're going to go around the circle backwards. Negative pi over 4 means you rotated backwards, so down first. That's going to be this point right here. What would that give you? -1. Negative pi over 2. So again, look, I'll just point to it. If you go backwards pi over 2, that's going to put you right here down at the bottom of the circle. That would be -1 over 0. So that is undefined. Good. -3 pi over 4. All right, if you go backwards 3/4 pi, that puts you right here. What is that going to come out to? That'll be +1. Good. The negatives are going to cancel. And then negative pi is the same as positive pi, so it'll come out to be 0. So we're going to put those on the graph. You're going to learn a new shape of a graph. We did the waves for sine and cosine. We did the U shapes for secant and cosecant. This is just going to be a different one. I don't want to slide the paper up and down and make you see 6. You're going to have to look at what you have on your paper. At 0, we start at 0. Good. And then the next one was 1. And then an asymptote. And then -1 and then 0. I realize that's where it runs out. So let me explain what happens when you keep going. You will get -1, 0, 1 asymptote. -1, 0, 1 asymptote. That's the pattern that's going to happen here. -1, 0, 1, and then another asymptote. And you'll see that when we went backwards, negative pi over 4 gave you -1. Like the exact same thing is going to happen going the other direction forever and ever and ever and ever. So when you connect those, you have to stay in between the asymptotes and they end up looking like this. And so I try to draw it as fast as I can so I can get my hand out of the way so you can see it, but they end up looking like this. They're not technically cubic graphs. This is a trigonometric function. If you call them cubic, I'll forgive you that I get it. They're just wiggles. You have an infinite number of little wiggly things forever and ever. That's cool, right? It's neat. It's a cool graph. All right, so we're going to list the same things that we did on the other ones. Again, my idea being you have this little exploration for each of them and you can like do a compare contrast. So we're going to start with domain and range and actually do the range first. What's the range of this if you sweep downwards to upwards? Yeah, that's everything. That's an automatic answer. On your test, that's the answer. Kind of like for sine and cosine, how the domain was all reals. For tangent and cotangent, your range is going to be all reals. So that's kind of nice. All right, so this is going to be written the same way because you have all those asymptotes. So it's all x except for, where is the first asymptote on this one? The first positive one. Pi over 2 is where the first one is, plus however often they happen. So look, we've got one at negative pi over 2, positive pi over 2, 3 pi over 2. How much space is in between pi? So plus pi n. It is discontinuous Can I say obviously? I don't like to say obviously very often, but obviously discontinuous. Even or odd. So look, do you see how this part up here reflects down to here through the origin? What does that mean? Through the origin means odd, origin odd. Let's try and review the other ones. Sine and cosecant, remember they go together. So sine and cosecant were odd. Cosine and secant or even, yeah, good. And then tangent and cotangent are going to be odd as well. All right, the amplitude again is none. That's only for a wave, so it's just by definition going to be none, which is nice because it's easy. But you know, I have people mess that up because they just forget. Just remember, it's none. Just write none. And then the period is a little different for this one. Do you know how for all the other ones it was 2 pi, and we were like, hey, that makes sense because you went once around the circle. For this one, do you see how one of the little wiggly things is only pi? This time the period is only pi. And the reason for that is to get one full cycle, because you have these rest stops, you only need to go halfway around the circle. Do you see what I'm saying there? All right, now hold on, I'm gonna say one more thing, then we'll flip it over. For the warm-up that we just did, you know how this was half the period? For tangent and cotangent, it just is the period. Like whatever you're adding on, that just is the period. It's not half of it anymore because you only go halfway around the circle. So I'm going to do the same thing I did with all these other sheets. We're going to flip it over. I'm going to stop talking, let you guys try it. The only difference is for cotangent, how do you get that? When you go around your circle, how do you get cotangent? Yeah, perfect. Good. X over Y. Go give it a shot. All right, how is this going? Okay. Did you get undefined for the first one? Okay, so you're going to start with an asymptote for this one at 0. And then what's your pattern? After the asymptote, it goes what? Yeah, 1, 0, -1, and then another asymptote. So it's going to be 1, 0, -1 asymptote. So what do you notice about this one that's different from tangent? Like what just jumps out to you first? It wiggles in the other direction. That's really what I was looking for. It decreases instead of increases. See what I'm saying? Cool. So your domain, everything except, all right, where's the first one? Yeah, 0 pi plus, how often are they happening? Pi n. Your range is everything. That's going to be an automatic answer. It's discontinuous. We've written that enough times. You don't need to write that again. I do want you to write that it's odd though, but they go together. If tangent was odd, cotangent is odd. The reciprocal ones go together. All right. What else did I put? Oh, amplitude is what? You're like, why is she hammering that so hard? Because people mess it up and I want you to get it right, all right? None. It's only for a wave. And then the period is just pi. You only go halfway around the circle to get one full cycle. You don't need to go the whole way around because you have those little rest stops. So let's go ahead and put in the automatic stuff. What are a couple there's 2 like automatic answers that you don't even have to do any work for out of these things for tangent. What can we do? Yeah, good. Your range is going to be all reals. Amplitude, none. That's the answer for range and amplitude on this whole paper. Like that just is the answer for those. All right, here's where this is different. For the period, it used to be 2 pi over b, whatever's in front of the x. Now it is just 1 pi over that number. Again, for tangent and cotangent, it's different. You only have to go halfway around the circle. So it'll be pi over what number? 1/2. All right. Dividing by 1/2 is the same as multiplying by 2 because you flip it over. So 2 pi. All right. How about phase shift? Yeah, none or zero, and then vertical translation is also 0. It is always nice when the phase shift is 0. It's when it gets shifted that stuff gets more complicated. So it's always nice when you start at 0 and then you add the period, which is 2 pi. So interestingly, this one just ends up being like your basic unit circle values. Like you're going to have pi over 2 pi, 3 pi over 2. Which weirdly, do you remember how I told you if you get stuck, that's what I told you to guess? Bless you. Do you remember that? Like if you totally lose your mind, just pick those numbers. All right, so we're going to go around our circle, but only halfway. We're only going to go halfway around. And for tangent, we're going to do y over x, and then we're going to multiply it by 2. So whatever we get from our circle, y over x, we're going to multiply it by 2. So here we go. Or you can look behind me. I have it on the board. For your first value, 0 over 1. It's one or the other. 0 over 1 is 0. Good. Times 2 is 0. Perfect. All right. Now we're here. We're only going to go halfway around. We're not going to use this part of the circle. So we're right here. I know that looks crazy, but anything over itself, 1 times 2 is 2. So 2 goes right there. All right. Now up at the top, y over x. So you have 1 over 0, which is undefined, times 2. You can't do an asymptote times 2. Like that just is an undefined. Now we're over here. What does that give you? -1 times 2, -2. And then the last one is always the same as the first. You always end up back where you started. Once you have that, you're just putting that information on the graph. You want to count these by halves. So what I would do is skip the first one and then call the second little tick mark pi. Skip 1, 2 pi, skip 1, 3 pi. I'm going to kind of just shut my mouth and let you guys put your points on there. I don't think that part is going to be too bad. It's going to go -2, 0 to asymptote. -2, 0 to asymptote. And just like with all the other ones, I want you to show 2 cycles of it, which means you need 2 wiggles. So 2 little wiggly things. You can do more if you want, but that's the bare minimum. All right, and then your domain. It's everything except, all right, where's the first asymptote? The first positive one. Pi, you see that right there? Plus, now for secant and cosecant, it was half the period. For tangent and cotangent, it's just the period n. So it'll be plus what? Yeah, 2 pi n. And you can see that on here as well. Like you have one at pi and then the next one's not until 3 pi. So there's 2 pi in between there. So you can use the graph to, back you up on that one. Cool so far? You're so quiet. I just assume everybody's okay. This one, do you see that -2 out front? It always baffles everybody when that gets put out front. So my first suggestion is scribble all that out and put the -2 at the end. I don't know why, but or if you're fine with leaving it out front, that's fine. It doesn't matter what order it's written in. But scribble that out and put it at the end if you're worried it's going to bother you. Next thing we have to do is factor out the 4 from in there. If you have more stuff, then you have to factor it. Like this one was just a 1/2 x. There's nothing to factor, but here we're going to have to do GCF for that. So 1/2 tangent, leave a little space, -2, and we're just going to do greatest common factor, take out the 4. And this is so you can see what your phase shift is. So if you divide out a 4 from both of these, what would you have left? Yeah, good. X minus pi divided by 4. And again, if you want to check that, if you were to distribute the 4 back through, you would get what you started with. All right, sweet. Range is everything. Amplitude's none. So like those 2 points, you're going to get those points no matter what. You've been paying attention. All right, so you guys tell me, what else can we fill in though? Phase shift is pi over 4. Perfect. Right pi over 4. down to, yep, good. Good, it's just pi over whatever, and what's the number for this one? 4, good. Sweet. Since those are both fourths, I think that the fractions get super tiny. Let's review really quick then, before I even get to this. Halves break down into fourths. Fourths break down into eighths, and then it's 16ths, and then it's 32nds. I don't know if we have to go all the way to 32nds. Then in theory, it would be 64ths. I know it doesn't go that far, but I think these break down pretty small, so just hold up. All right, where are we gonna start? Because it's not 0 this time. Yeah, pi over 4 is your phase shift. And then you add the period. Weirdly, they came out to the same thing, but that's coincidence. Pi over 4 plus pi over 4. A fourth plus a fourth is a half. So figuring out what's halfway in between those. This is 1/4, and this is 2/4. So we're going to have to break down the fourths into eighths. So how many eighths would this be? Be 2/8. And this would be 4/8. Good. So good. 3/8 is halfway in between. Do you see how we did that? You have 2/8 and 4/8. 3/8 is in between. Now we are going to have to break down to 16ths. So how many 16ths is this? 4/16. This one would be 6/16, and this one would be 8/16. Just write yourself a little note. I mean, that's what I do. That's your brain working. Like, those are your thoughts. And then you can see what's in between. Because, hey, guys, what's halfway between 4 and 6? 5. So this would be 5/16. And then this one would be 7/16. That one was hard. I think that's the hardest one we've done so far. But, and before I even get to this, what's the easiest way to make each of these a 16th? Go to the 16th one and call it pi. Good. Go ahead and do that. I think it goes out far enough. Yeah, go to the 16th one and call it pi. If you want to have a few more labeled, you can go to the 8th one and call it pi over 2. That's honestly good for this one. I mean, because it got so stretched out. All right, so we're going to go around our circle, actually only halfway around our circle. We're going to do y over x for tangent. Tangent is y over x. And then what are we going to do to those numbers? We'll do y over x, and then what? Divide by 2 or times by a half, however you want to think of that. And then minus 2. Perfect. All right, here we go. 0 over 1. 0 times a half is 0 minus 2. Good. All right, we're all on board. Now we're here. Again, we're only going halfway around. So what does this one give us? 1, a half minus 2, negative 1.5. I'm fine with that being a decimal since it's the output value. So it's fine if you want to put that as a decimal. What would that be in fraction terms, though, just for being thorough? It'd be negative 3/2. Yeah, good. Cool. All right, now we're up at the top. 1 over 0, undefined. Over here, negative 1 times a half would be negative a half, minus 2, negative 2.5, and then you're back where you started. So go ahead and put it on the grid. It's going to go negative 2.5, negative 2, negative 1.5, asymptote. Negative 2.5, negative 2, negative 1.5, asymptote. It'll be a little progression, and then you can make it a little wiggly thing. Oh, I messed something up. Oh, there we go. And then we're gonna go back and get the domain. So where is the first asymptote, the first positive one? It's at the second tick mark, but what did we break them all down into? 16ths. So it would be 2/16. Honestly, I'm fine with you writing 2/16, but what does that reduce to? Yeah, 1/8. So pi over 8 plus, and then what? Yeah, it's whatever the period is. So pi over 4n. So again, that one just is the period, tangent and cotangent. Because you only go halfway around the circle. Secant and cosecant, it's half the period. One more thing for you have to remember. Yeah, you can write 2/16. I just reduced it to 1/8, but that's the right answer. Do you see how the first asymptote is at the second tick mark? Look where I'm pointing. Do you see how it's at the second one? So it's at 2/16, but I just reduced it to 1/8, but you could write 2/16 if you want to. That's where the first asymptote is. That one was hard. Because without looking at it, it's kind of hard for me to tell. All right, do I need to factor this or not? Yes. Do you see how we can factor a 2 out? We're gonna do greatest common factor, factor out a 2. So you can see what your phase shift is. That one's not too hard though, because they both have a 2. If you factor out a 2, what's left? Yeah, x minus pi. I mean, just the other stuff, right? All right, so fill in the automatic stuff. And then you're like, hey, I know I got my points for that. What else jumps out at you? Like, you want to fill this out in the order in which it like feels natural for you. Like, what's that? Bless you. What's the next thing you see that you're like, hey, I know that answer? Yeah, I think that's the next easiest thing. That would be 1. How about the phase shift? Yeah, write pi or just pi, and you can put that right here in your table too. That's going to be the first thing. And then the period, instead of 2 pi over whatever, it's just 1 pi over whatever. And what is that number? 2. Sweet. Get like half the points already for the problem. So we started with pi, that's our phase shift. We're going to add the period pi over 2. So if you do pi plus pi over 2, 3 pi over 2. I think we're going to have to break this one down too, but I don't think it goes all the way to 16ths. This one might only go to 8s. We'll see what happens. All right. But to get what's halfway in between these, this is 2 halves and this is 3 halves. So I'm going to have to break it down further into fourths. How many fourths is a whole 1? That's 4 fourths. And this is 6 fourths. So what's halfway between 4 and 6? 5, so 5 fourths. So yeah, we are going to have to break down into 8s. This is how many 8s? 8 8s. 5 fourths would be 10 8s, and 6 fourths would be 12 8s. If you can do it in your head, that's really cool. I just have to write it out. Like, it just helps me to write it out. So then what would go in this blank? Halfway between 8 and 10. Yeah. 9 8s. And then 11 8s. Cool, fun with fractions. So when you go to label this, if you want to even do that right away, just go to the 8th tick mark and call it pi. Go to the 16th one and call it 2 pi. And then you've got it. You don't need to label more than that. All right, so how do we get cotangent from our circle? We're about ready to go get our y values here. X over y. So we're going to do x over y and then plus 1. So here's our first one. 1 over 0. Undefined. Good. And then you're right here. So what does that give you? 1 plus 1 is 2. 1 plus 1 is 2. All right, then you're up at the top. 0 over 1, 0 plus 1 is 1. Could you keep it going after that though? Like it's gonna go 2, 1, 0, and then undefined. Like if you can keep the pattern going, you don't need to go through the whole circle thing. All right, so go ahead and plot those. At pi, you have an asymptote. Did you do that already? Oh, goodness. You did the last one too? Jeez Louise, wait for the rest of us mere mortals here. Can I make a suggestion here? When you go to do the second cycle of it, instead of going to the right, go to the left. Why would I suggest that? Like, why should you fill it in this way instead of over here? So that you get the first asymptote. And in fact, I know you said you only need 2. You're going to need to do a third one so that you can see where it starts. You have to get all the way back to the beginning so you can see where the first asymptote is. Without sitting right next to you and looking at it together, I can't fix that. So let me finish this one and then we'll do that, okay? I can't fix it from over here. I can fix it, so don't worry. It's a fixable thing. I just can't do it from my tobacco series. Not reaching to go that far. All right, so go back for the domain. If you go back far enough, where is actually your first asymptote? Yeah, do you guys see how it ended up being on 0? So you have to go back so you can get the first one. So 0 pi is the first one, or I guess if you don't want to write that, plus what? Yeah, pi over 2 is the period. So pi over 2 ed.